In this lesson, we will look at the forces that oppose current flow in AC circuits, and we will examine the relationship between these forces. We will start by looking at theoretical circuits containing, in isolation, resistance, inductance, and capacitance. Beginning with resistance. In a theoretical AC circuit containing only resistance, the voltage and current are in phase, and Ohm's law applies. Resistance can therefore be calculated using the formula R equals V divided by I. The opposition to current flow in a circuit containing inductance is called inductive reactance. It is called reactance rather than resistance because it varies with the frequency of the supply, as well as the value of the inductance. Inductive reactance is measured in ohms and is given the symbol XL. To determine inductive reactance, the formula XL equals 2 pi FL is used, where pi is a constant, F is the frequency, and L is the inductance in henries. The formula itself is of little importance, but we can see from it that for a fixed value of inductance, the inductive reactance will increase if the frequency of the supply voltage is increased. This will lead to a decrease in the current flow in the circuit. Conversely, and more importantly, if the circuit frequency decreases, the inductive reactance decreases, and the circuit current increases. The opposition to current flow in a circuit containing capacitance is called capacitive reactance. As in the inductive circuit, the amount of reactance is dependent upon frequency and the capacitance in farads. Capacitive reactance is measured in ohms and is given the symbol XC. It can be calculated by using the formula XC equals 1 over 2 pi FC. Again, the formula itself is not of any great importance. However, from the formula, it can be seen that as frequency increases, capacitive reactance decreases, so the circuit current will increase. Conversely, if frequency decreases, capacitive reactance increases, and circuit current will decrease. The total opposition to current flow in an AC circuit is a combination of resistance, inductive reactance, and capacitive reactance. It is known as impedance. It is measured in ohms and given the symbol Z. Because of the differing phase relationships between the voltage and current in inductive, capacitive, and resistive components, inductive reactance, capacitive reactance, and resistance cannot simply be added together. Inductive reactance can be thought of as having the opposite effect to capacitive reactance, as one effect causes the current to lag the voltage by 90 degrees, and the other the current to lead the voltage by 90 degrees. So their effects on current flow are 180 degrees apart. Total reactance can be found by subtracting the smaller from the larger. The current flow in a resistive circuit is in phase with the voltage, so resistance is out of phase with the total reactance by 90 degrees. Impedance is the vector sum of resistance and total reactance. Because the resistance is 90 degrees out of phase with the total reactance, we can use Pythagoras' theorem to calculate the impedance. The formula for calculating impedance is being displayed on the screen. Changes of supply frequency in a circuit will have the opposite effect on capacitive and inductive reactance. The manner in which the inductance and capacitance react in an opposite way to changes of supply frequency means that there will be one specific frequency for each circuit at which their reactances will be equal. When the capacitive and inductive reactances in a circuit are equal, the circuit is said to be resonant. The frequency at which this occurs is known as the circuit's resonant frequency. Radio tuners often use resonant circuits for their operation. That is the end of the lesson. Here are the main points that you need to take from it. Reactance, measured in ohms, is the opposition to current flow produced by inductors and capacitors. For a fixed value of inductance, the inductive reactance will increase if the frequency of the supply voltage is increased. This will lead to a decrease in the current flow in the circuit. Inductive reactance will decrease if the frequency of the supply voltage is decreased. This will lead to an increase in the current flow in the circuit. For a fixed value of capacitance, the capacitive reactance will increase if the frequency of the supply voltage is decreased. This will lead to a decrease in the current flow in the circuit. Capacitive reactance will decrease if the frequency of the supply voltage is increased. This will lead to an increase in the current flow in the circuit. Impedance, measured in ohms, is the vector sum of resistance and total reactance. When the capacitive and inductive reactances in a circuit are equal, the circuit is said to be resonant. The frequency at which this occurs is known as the circuit's resonant frequency.